Hello, everybody. Welcome back to the Elastic Live user group. This is the North and South American virtual user group where we take our lunchtime to talk with someone, whether it's inside of Elastic or outside of the company that's using Elastic or just talking about tech in general. And we hopefully have some questions that we can ask. And this week is no different. We're continuing our client series. I think this is actually the last of the clients that we're running through before we have to bring y'all all again because 7.14 just came out, 7.15 is coming out, 8.0 probably coming out sometime next year. So we'll just keep rinsing and repeating until it happens. But I have Enrico Zimuel with me. Enrico, how's it going?
Good, good. Hello to everyone.
Let's kick it off as we normally do. Enrico, tell everybody a little bit about yourself, how you got to Elastic, and ultimately how you got to be in charge of the PHP client.
Sure. So I start to work in Elastic. Now it's 2 year and a half, mostly. Yeah, it will be 3 years in March next year. So, I was working for Zen Technologies. That is the company behind PHP, basically, founded by Andy Gutmans and Ziv Soraski, the two creator of PHP version 3. So I was deeply involved in the PHP community. In open source, I'm the co-author of 3 big projects in the PHP arena that are Zen Framework, Appagility, and Expressive. And after 11 years, even because the Zen company was acquired by another company, I started to look around for new challenging, and I found the job offer from Elastic about PHP, the PHP client. So I think was interesting. I was intrigued about Elasticsearch. I was not definitely an expert of Elasticsearch, so this also gave me the opportunity to to learn more about searching algorithm, searching use cases. So here I am.
I love that. Like most of the people that I've talked to at Elastic, when they got to Elastic, they were not advocate users of. They weren't like the heaviest of users of
Yeah,
Elasticsearch. So I think that leads something to the company having that thing that just brings people in and puts them in a position of leadership, even though they aren't necessarily the most long experienced people in the community as a whole, which is great because that means we're always looking at the outside to bring them in. But also, how has over time your knowledge of using Elastic uh, grown? Like, I mean, do you still feel like you're still not the biggest user of all of the tools in Elastic, or do you feel like since you have to develop for it, you've kind of grown to learn more and more about it?
yeah. I'm learning day by day. Basically, I grow. Of course, the first month was like crazy because from almost 0 to 100 in 1 month. Because as you said, we have to build the software in order to use Elasticsearch. So we need to understand deeply all the API, and we are talking about around 400 APIs. So it's a lot with all the parameter use cases. It's a challenge, of course, but especially in the clients team, this is quite popular in the sense that we are expert in each field. So JavaScript, PHP, Ruby, .NET, Go, Java. So that's why I think they build this team to think about experts that had a previous background in open source, how to create a library, community, and because as you know, the most important part of open source is community. It's not only technical; it's very, very important to have people behind the community. So that's why I think we are not really heavy users of Elasticsearch in the beginning. Now, of course, we are because after almost 3 years. But again, Elasticsearch is a very nice project, a lot of feature. So you literally learn every day how to use it, how to improve it. New feature coming every 2 months, so it's quite hard also for us to be, aligned with the new proposal of the company. So
Awesome. Well, I love that you mentioned, there are over 400 different APIs to cover. And I will be honest with everyone that's watching, we're not going to be covering all 400 of them.
yeah, absolutely.
we got about an hour. So we're going to be hitting some of the wave tops on this. But if you have any questions that, for Enrico while we're here, you can feel free to throw them in the chat. Let us know. Also, if it's something that we don't cover that you're interested in, go check out our Discuss channel. We have a forum there where people are asking questions all the time. The way I often tell people, we have elasticians, technicians, and all other issues of every kind in there that are just hoping to help folks get the solutions that they're looking for. And I know that Enrico has done a few other presentations, and we do presentations all the time. There are plenty of events that are happening throughout each and every week. And that's going to be at community.elastic.co is where you can find that information. And last but not least, I would be remiss if I didn't let everybody know that ElasticCon Global is coming up, and be sure to look out for that. Be sure to RSVP and sign up for that. There's going to be a bunch of talks. I've been helping some folks with talks. I'm super excited to hear about it. I'm not sure how many are PHP specific, but I know that there are plenty that are going to be happening around the Elastic Stack as a whole. And you can find more about that at elastic.co. So Enrico, let's talk a little bit about the PHP client. How is it similar and different to some of the other clients that we have?
Good question. Is I would say similar to other, languages, dynamic languages like, JavaScript, Ruby, Python, for sure. Not so similar with the others like, .NET, where you have more object-oriented, more abstraction, actually. At the moment, the PHP client, we say that is low-level client in the sense that gives you the possibility to, connect to Elasticsearch, managing the connection pool. That is a feature that all the clients support. So basically, you don't have to manually, pick up one of the node and send a request to the specific node. You can just specify, look, this is my set of nodes, my cluster in a configuration, and the client will basically, using a round-robin algorithm, spread all the communication to all the nodes. So this is a feature that is common in all the clients, and I think it's a very good feature because you basically don't have to care about the architecture of your cluster. Everything is managed by the client itself. So the difference are basically, as I said, as a developer experience, how you perform an HTTP request. That in the case of Elasticsearch PHP is just a function that you have to call into an object. The object is a client object. So basically, the flow is very simple. You create this instance of the client as an object, and you can perform all the APIs just calling the name of the function that is the same name of the API. That's it. Very, very simple. I will show some example, of course, but this is basically, the background.
And of course, we know that PHP is still kind of how the internet runs in many cases. A lot of folks like to look at JavaScript to that, but I remember many a time where PHP was the thing that was just pushing the internet and getting that data to you. How does Elasticsearch and the PHP clients work in incompatibility with some of those PHP tools that are out there that people are using, such as like Laravel, and of course we know WordPress is kind of a big deal?
Yeah, it's very simple in the sense that the client returns you an associative array that is the body. So it's first of all, the communication between each client and Elasticsearch is provided using REST API. using JSON. So if you want, you can just send using any HTTP client in PHP, for instance, using Gazelle, just to perform a specific API, but you have to know all the the parameters, the methods, the headers. You have to manage by yourself the connection pool, or you can use Elasticsearch PHP. That gives you basically the input is an associative array, so the parameter, the body of the request. So for instance, if you want to index a document, you have a document inside an array, you just put and call it index function, and you will come back with a deserialization JSON. Is an associative array as well. So it's very simple to integrate in every PHP project, and there are a lot of community libraries that consume the Elasticsearch PHP client in order to integrate into Laravel, as you mentioned, or WordPress. It's very, very simple to integrate in all the PHP projects out there.
Well, I will say you've exhausted about most of my knowledge around the PHP clients and PHP as a whole. So I am very much eager to learn how we interact with Elasticsearch using PHP. People tend to forget this live stream is for me, because in many cases I'm the beginner that's like, hey, how do I do this? So I'm going to turn it over to you, let you go ahead and share your screen, and then walk me through the process of using this PHP client. And folks, again, if anybody has any questions as to what Enrico's doing, or if you mentioned something, you're like, hey, what is that? Let me know in the chat, and we will be happy to get that answered.
Okay, cool. So let's start from scratch, of course. So the first thing is to have an Elasticsearch instance running. So the idea is to you can do, can install manually, or just we can use Docker, because we offer in our dockerelastic.co. So this is our website where we store all the Docker images of Elasticsearch. So we do this example. So maybe I can increase a little bit. I don't know if it's big enough. You can pull an image of Elasticsearch. In this case, I'm using the 741 version, so it is the latest. And the other command, this is standard Docker command. It's running basically this instance using the default port of Elasticsearch, that is 9200, because as I mentioned, Elasticsearch is a server application that communicates using HTTP specific port. So we can run actually. Let me run in another window. So basically, here I'm just running the Elasticsearch. So I'm pulling down the Docker images, and now the Elasticsearch is running. Here you can see all the the dump, basically all the information, the logging messages of Elasticsearch. So okay, let's do this in the background. So now we are running Elasticsearch on it's just one node, of course, on my local machine. Let's start with an example. So let's do a test example here. So first of all, we need to have the Elasticsearch PHP client installed. So we can use Composer. That is the default way to install packages, libraries in PHP. So we need to write Composer require. The name is Elasticsearch / Elasticsearch. Of course, Elasticsearch. Okay, I spelled it wrong. So of course now I have everything in my cache. Otherwise, you will have some seconds in order to download all the packages. But as you can see, basically there are not a lot of dependency. So we have the main library, this is Elasticsearch, and we have a couple dependencies in order to manage basically the HTTP connection. So we are using Gazelle and the ring PHP I forked it because this basically is a library that is based on Gazelle, but was deprecated. So I forked it on my repository. So I'm managing it by myself. We are supporting the PSR for logging, PSR3 for logging, the PSR standard in the PHP world. And we are using promises from React because we also have asynchronous operation. So the Elasticsearch PHP client gives you the ability to execute asynchronous call. So basically you can, for instance, provide a search, and this search is not blocking the PHP execution. So the PHP code will be continue to execute. So this is nice if you have performance issue, or if you want to boost your application. Okay, so now we are ready. So the Elasticsearch PHP library installed under the vendor folder. So we can create our first PHP script. Of course, we need to require the vendor autoload of Composer. This is quite standard in all the PHP projects. And now we can start creating for instance, performing I don't know, an info API, just to give some information about the cluster that is running the Elasticsearch. So the first thing that we need to do is to create a new client, and we have this client builder class that is a factory. So it implements the factory design pattern. Basically, we need to create the client. We need to specify the hosts. And this, as you can see, is an array, because here you can specify a list of all the nodes that you have in your cluster. In our case, it's very simple. It's just one. It's localhost 9200. And you can build actually the object itself, the clients. So basically, in one line, I wrote in 3 lines just to for a better format. But basically in one line you will get the client ready. So now you can actually perform any operation. I don't know, we can perform a very simple API that is info. As you can see, when I start typing, I just put the auto completion gives me the list of all the API, all the namespace actually that I can execute. For instance, we can have a info. Info is a very basic API that gives you just information about the status of Elasticsearch, and we can let me print our dollar results. Okay, so basically now we can execute this simple script. Again, I'm here in the console. We can just run from the command line. And as you can see, the result is an array. So this dollar result is an array that contains some information about the status, of the instance that I'm running on my machine. The name of the instance, the cluster name, because it's a Docker cluster, was the name that I used to run the Docker image. The version of Elasticsearch, that's 741. We have also some information about the build hash, because Elasticsearch is an open project on GitHub, and so you can even check the hash of the last commit with the tag 741. You have the build date. You have the Lucene version, because I don't know if you are familiar with the engine of Elasticsearch, but basically Elasticsearch internally uses Lucene as an engine to perform the search operation. So this gives you also the version of Lucene that is using Elasticsearch. And we last but not least, we have our famous tagline, for search. So this is basically a very, very simple API, but again, it's just calling a function with the same name of the API.
Just jumping in really quick with
Yeah.
that. I love that this is like always the, hey, let's do this just to make sure we're connected. For those watching, another thing that you can do with this is you can use this to verify the version number. to make sure that, if you're connected to the right, if you're connected to the cluster, of course you can check the cluster name, but most of our code isn't breaking. Most of our updates don't go back and break. We do have a few times where that happens with like some major releases. So I think there are often times where you may want to execute different commands based on the Elasticsearch cluster's age and the version of Elasticsearch that you're working on. Again, that's one of those things where it's not like, it doesn't happen often, but if you're like debugging or if you're optimizing for production or if you're trying to work at something where you're scaling it and you might have some older Elasticsearch instances, that might be a thing to check.
Yeah, and again, because everything is a very simple associative array, you can just, I don't know, version number, you can just print it as a result in the array. So the first name is version. You have to pick the number. Run again this this simple script, I will get back the information. So as you mentioned, you can check it out if your application is compatible with a specific version of Elasticsearch, because maybe, I don't know, you are using some a feature that has been released, starting from a minor version, for instance, like schema on read. That's something that we released recently. So you can check, as Jay said, very, very easily the version number. Okay, let's jump to a more interesting example. In order to reduce the time, I already created some example here. So basically, we want to index a document. So the first operation, of course, is to store something into Elasticsearch. How we can do that? So a document basically for Elasticsearch is a JSON document. For PHP can be also a JSON string. I will show you how to do that later. But generally speaking, is an array, an associative array. So imagine that you have this information. You have, I don't know, account information with an account number, the balance, the first name, last name, the age, gender, and so on. And you want to store this information, this document, into Elasticsearch. You can use the index operation. So the index basically is the meaning of storing, of saving data into Elasticsearch. So indexing. So that's the verb. And you basically need to perform to specify some information here. The first is the name of the index. So an index, if you want to compare to a SQL relational database, is more or less like a table. In an index, you have a name like a accounts table, and inside you can have all the documents. Of course, there is a big difference with a relational database. In a relational database, the fields are almost the same, so you have to define the structure. Here is like NoSQL, basically. In Elasticsearch is a kind of NoSQL, database. So you can actually put whatever you want into the document. So whatever JSON. So that means, for instance, for some information you cannot have, I don't know, the address. For other, you can have it, or putting other, information as well. Anyway, the first parameter is the name of the index, accounts in this case. You can specify the ID. Actually, we can also don't specify the ID, just let Elasticsearch create the ID for the specific documents. And the second parameter is the body. The body represents the request that you want to send to Elasticsearch. In this case, is, as I said, an associative array account. So let's see what this example does. So the name is, the name is index. Basically, it executes the script, and at the end I have a var dump of the results, total results. So let's see what happens. So basically, we have an array. Oh, actually, let me print. Maybe it's better print. Okay. Now I think it's you can read more easily. So basically, we have the account, the index account that we use it. The type doc, because this is a document, so this is some internal type of Elasticsearch, and this is the ID. So basically, we created the document, this document here, and Elasticsearch stored with a specific ID. So the ID is created automatically by Elasticsearch. You have also the version. So this is another cool feature of Elasticsearch. So basically, each time you insert or update a document, the version is incrementing, and this is used for to have consistent data inside the database. There is also a possibility to have the version outside Elasticsearch. That means, for instance, you have a MySQL database with a table. You want to insert the table in Elasticsearch. You can even have used an external version coming from, I don't know, MySQL, Postgres, or whatever. And we have the results. So as you can see, everything that starts with the underscore is something managed internally by Elasticsearch. If you don't see the underscore from the name, this is more, for as I would say, output as a result from the API. For instance, here we have, the number of an array that contains the shards. That is an internal information. But the most important one, I would say, for our example, is the results, because in the results you have the created results. So that means the index was successful, and Elasticsearch created this document inside the engine. Of course, now that we created something, we want to read it. So the read is very simple. It's basically a get. There is this API get that performs the read. Basically, you have to specify the index name and the number of the ID. In our case, for instance, let's copy and paste this one. This is the ID that we just created. And sorry, we have to run the get. As you can see, we have the response here, the dollar results, and the get is actually the the information about the document. So the index is account, the ID is the one that we provided here, and the actual body is under the the underscore source field. So as you can see here, we have all the information about the data that we put before. So Amber Duke is the first name, the last name, and so on. So very, very simple. If we did a mistake, for instance, let's see, I don't know, id foo that does not exist, and we perform another get, we can try catch, because basically the PHP client, if you specify an ID that does not exist, it generates an exception. In this case, it's a missing 404 exception. As you can see here, there is the full namespace of the exception under the common exception. And in this way, you can catch the exception. And I just put some message here: the document doesn't exist. This is actually the message, the get message. So this is the usual way where you can, in an exception in PHP, get the message of the exception. And this is actually the response from Elasticsearch. So this is the exact JSON that Elasticsearch provided you in case of error. As you can see, there is a found false. That means the document does not exist.
Enrico, if you didn't run that 404 exception catch, would it result in an error, or would it just say like nothing happened here?
Yeah, so if we comment the Trycatch, we can try to run again. You have a PHP Fatal Error, because basically each time an application in PHP execute an exception, throw an exception, of any kind, PHP will stop the execution as a fatal error. So you have to use Trycatch in order to protect the execution of the get in this case.
Okay, I know that there are some other I guess error messages. So like we have a 404, we have a 400, and there are a few others. I know that in some of the clients there is a way to ignore some of those, especially when you're dealing with something like if you have to re-index data. Sometimes it's easier to do like an index dump at the very beginning and just say, hey, do this dump and don't freak out if there is no index to dump. That way, like that's fine. Is there something similar in the PHP client?
You can just say, okay, let's try catch with the elastic exception. That is one Elasticsearch exception, and you cannot perform nothing. For instance, this, or you can actually even if you know specifically, for instance, that you don't want to have a 404. You want just to ignore the 404. You can actually do something like this. So you can specify in the client. So this is a special key for the Elasticsearch PHP, where basically you can customize the execution of the HTTP client inside the Elasticsearch PHP, and you can write something like this in your 404. And basically, if you specify this, the Elasticsearch will not throw the Elasticsearch PHP will not throw an exception.
Okay, that's what I was thinking of. I saw the try except, and I was like, okay, is that a is that a thing?
Yeah.
But I see here.
Yeah, you have the both. The two options. By the way, in the majority of the modern PHP project, because everything is object oriented, Trycatch is quite popular from the PHP people. But if you know that you want to omit specific error like 404, you can just add this in the parameters of the API, and this actually will not throw an exception.
Gotcha.
So in this case, the result is the result from Elasticsearch. That was, by the way, the same that we had, catching the exception from the get message, but the PHP is not blocking, so you don't have a fatal error. Of course, you need to check manually in this case. So if the found was true or false, you know what I mean? If you want to, but again, if you already know that you don't care about 404, you can just pass this, and you don't have to try catch or check nothing basically.
Yeah, and again, for me, like I have only had to do like an ignore result, like ignore 404 or 400 error. Usually when it's like I'm indexing a bunch of information, and if something happened the first time, like I have a delete index field in there that is just, hey, in case I run this a couple of times, like if it ran too early or something like that, then delete the index. But in most cases, that index won't exist. But I know that I'm just making sure that if I do have to index it again, it deletes the first index and prevents, a 400 error.
Yeah, exactly. Okay, so I just show how to index, how to get. Let me show how to update documents. So the basic operation. There is an update API, so very, very simple. You need to, again, specify the account, the ID. So let's check for the ID. So imagine that we want to change this ID here. So we want to use already this document ID, and we want to change, I don't know, the age was 32. Let's change to 33, for instance. And let's see what happens. So PHP, update PHP. So now we have the response back. As you can see, there is just updated the results. You don't have the actual object, the document in the response. So if you want to be sure that this ID has been updated, of course you can use the get, and we can perform the get. Yes, but we are not. Okay, and as you can see, the age now is 33. So we changed basically the age. And you notice that you can just update just one field in the document, but you can also add another field, because as I said previously, Elasticsearch is a NoSQL database. You can add field on the fly, basically. Okay, the last operation to fill up the crude example is the delete. How I can delete a specific document? Very, very simple. We have a delete API. You have to specify the index name and of course the ID. So imagine that we want to just remove the document that we created. We can delete it. As you can see, the result now is deleted. And if we get back, we don't have nothing because found is false. So if we go back here to the Trycatch and we remove the client in your 404, it should generate an exception. And using the Trycatch, actually, let me move this inside the Trycatch, otherwise we'll have error. Document does not exist because we deleted. So basically, I show you how to insert, how to update, how to read, and how to delete in Elasticsearch.
And it's very much that like you said, that CRUD methodology of like client dash arrow or arrow create, update,
yeah,
and delete.
and delete.
I guess
yes,
you have the get of that as well, which is kind of the read in that process.
Yeah, actually, I'm planning also to, because this is something that I started to do for an article that I published for the PHP article. That is a famous, popular, PHP magazine. And I wrote an article how to use Elasticsearch with PHP. This has been published on July this year. So I collected a couple of examples, but I'm collecting, very long. Actually, I can show you. So here, basically, we have a lot of example, different kind of search, bulking, logging, even schema on read. A lot of other, example. I'm thinking to publish, a repository to open all these examples. So of course we will share the details when I finish this project. So
Absolutely.
as you know, everything we love to share with other people, and sharing code is every time funny, because you receive also a lot of feedback and you can grow. And even this will be a public repository, so people can even contribute with crazy example or scenario, whatever. Another example that I would like to show you, because this is very, again, basic operation, but I think this will be more interesting, is the bulk. So imagine that you want to index not just one document, but you want to index a set of documents, let's say 100 documents. The beauty of this API is that basically that you can specify 100 documents in just one body and perform just one HTTP request. So you don't have to perform 100 HTTP requests. You can just perform one single HTTP request. So this is very convenient, I would say. So how to use the bulk operator in Elasticsearch PHP? This I think is interesting to also to mention for the audience. As I mentioned, Elasticsearch, this is the official website of Elasticsearch about the documentation. So this is Elasticsearch Guide 7.14, REST API, Documents API, Bulk API. So basically, if you go to the documentation, all the REST API are, documented, of course. And you can have a look at the Bulk API, the one that I want to show you now. So here you have an example. So you can even copy and paste using the curl. Curl is a famous HTTP client that you can pull in your shell, or you can use also Kibana and view in your console, whatever you want. But let's talk about PHP. So basically, if you read this example, let's say, okay, if we want to post multiple documents, you have to create one single body where contains the first line is basically the operation that you want to perform, and the second line is the document. And you can actually, create more operation. For instance, you can. This is a bulk operation that index one document with index name test ID1. It creates, so it stores this document field one value one into Elasticsearch. The second operation is a delete. The third operation is a create, to create an index, an update, and so on. So basically, in one single HTTP, you can perform multiple different operations, not just indexing 100 documents, deleting 100 documents. No, you can even send an index request, a delete, an update, and so on. So this is very, very powerful. So this is mapped in PHP in this way. Basically, you have a bulk API, and you have to create in the body of the bulk, you have to create the operation, as in the example that I show in the online documentation. In this case, we are just indexing, so the operation is index. We are working on the same index that is accounts. So the first line is, as I say, the index operation. So we want to index something. This is the ID that we want to create. So this is just a number that I put here, the ID. So we want to create a document with this ID. So the second line is actually the document itself. So in the previous example, the accounts was this, first name, last name, all the information. I just put here name and surname. And the second, again, is another index, of course, using a different ID and a different value. So basically, this is a bulk that performs two indexes with two documents in one HTTP call. So if I try to run this, let's create another index. So okay, so basically this is the millisecond. It gives you the number of milliseconds that Elasticsearch consumes in order to insert these two documents. And these are the items. There is no errors, so error is empty, basically. The items are the document that I created. So basically, the first item is this one. And as you can see, we have basically the information. If you remember the index example that I showed earlier, are the same. Basically, the accounts 2 is the name of the index, the ID, the results created, and the second element is the second also created. That's the second document. It's also created. So that's it. Very, very powerful. Of course, now it's just a toy example because we have just two documents. But imagine that we have multiple documents. For instance, this is an example, a JSON example that we use also in the documentation of Elasticsearch with a number of accounts. Specifically, I think it's 2001. Yeah, 2002 accounts. Actually, the documents is the half, so it's 1 1001 documents, because remember, the first line is the action, the second is the document, so it's the half basically of the line in this case. So imagine that we want to perform a bulk operation to insert all these documents in Elasticsearch. We can actually perform everything in one shot, because Elasticsearch gives you the possibility to have, if I remember right, it's 10 megabytes with the 5,000 document or something like this. But just for for this example, I choose to split the document into 500. So I'm bulking 500 documents at a time. So we are performing, I guess, 4 HTTP call here. And what I'm doing is very simple. So this is pure PHP. So I'm reading the accounts JSON, the file. I'm of course specifying that I want to create an accounts index. The body is empty because the body is something that I have to create reading the information from this accounts JSON. And this is something interesting, because here basically I'm reading line by line for this account JSON. And as you can see here, I'm not converting the JSON string, because this is a string. I'm reading a text file here. So this is a string. I'm putting directly the string into the body. This is a cool feature of Elasticsearch PHP, because if you find online or in another project, if you have some JSON, for instance, like in the example that I show, you have this JSON here, and you want to use this as input of the function of Elasticsearch PHP, you can even pass a string. So basically, the dollar params that I showed here, for instance, in the get or maybe in the index, this one, as you can see here, the dollar account is an associative array. You can even specify this as a string. So just to give you so let's just to, I don't know, get the first line of this and put as is. So this will work as well. So you have two options basically. You can specify the body as associative array or the body as JSON documents. This is convenient if you copy and paste something from another project online, from the documentation you want to experiment. You can do that. And actually, I use this approach in this example because, again, I'm bulking, but I'm using the JSON. So I'm not, decoding from JSON to associative array. And because internally, of course, the operation that Elasticsearch does is to take the associative array, if we specify an array, and actually call the serialization in JSON. Because at the end of the game, the HTTP call needs to be JSON to Elasticsearch. So this is also a cool feature, because if you already have a JSON, you don't have to serialize and unserialize internally. So you can just put the line itself. So basically, I'm creating the body here. This is the concatenation, the concatenation operator, the dot equal in PHP. So this is concatenating a string. At the end of the string, another string. And I'm just counting. When I reach 500, I basically perform the bulk operation. So I call the bulk with the dollar params, that is the parameter. And of course, I need to clean the body, because the next time I want to start with an empty body. And I just added the end documents here. So very, very simple script. If we bulk all accounts, as you can see, we performed 4 HTTP call, where each basically HTTP call store 500 documents into Elasticsearch. Okay, so this is just another way to consume the Elasticsearch PHP client using again the bulk operator. The last example, actually, or one of the last examples I would like to show you is the search, because Elasticsearch is famous for this feature for searching.
For search.
For search. Yeah, exactly. So how we can perform a search operation. This is very, very basic example. Imagine that you want to just know, okay, how many documents I have in my accounts, index. You can just perform a search. You specify the name of the index, and I'm just getting out the total documents, the score it took, and also printing some information here. So let's execute this example. So this is just search PHP. So again, I'm not searching for any information. Just give all the documents. If we perform this, we'll have back this response. So we have basically number of documents is 1001. The maximum score is 1 because inside Elasticsearch there is this idea of scoring. So basically, when you search something, all the results have a score that is a floating number that gives you the quality of the results. So if you, I don't know, if you are performing a search looking for a specific term, Elasticsearch will provide also similar term, for instance, using the fuzzy search. That is a nice feature of Elasticsearch. And using the value, you can understand the quality of the results. So if the results is similar, how the distance between the results and the actual term that you wrote in your query. Anyway, in this case, it's just 1 because we didn't perform any search, just looking to all the document. This is the request, the response time. So basically, Elasticsearch consumes 382 milliseconds to perform this operation. But as you can see, they give also the results. So these are basically the documents that I stored into Elasticsearch, but only the first 10, because of course I cannot give you Elasticsearch by default does not give you all the 1001 documents. It's used pagination. So basically, by default, Elasticsearch gives you 10 response at the time. And of course, the next question is, okay, Enrico, but how I can iterate all the pagination, right? Because this is we have a idea of scrolling, basically. That is the pagination. So you can actually scroll into the results. How we can do that? We have the search API, as usual. You have to specify the scroll and the size. So these are the two options that you have to specify in order to use the scroll. So the first scroll is the number, is the timing of second between each request, the 30 seconds. So this is interesting. Why you have to specify this information? Because basically, when you perform a search on Elasticsearch, the results are stored into a snapshot for 30 seconds, and you can perform the pagination on all the results for 30 seconds. Why? Because if you have an Elasticsearch cluster with a lot of data, maybe the data are changing. Even when you are searching, can change from one page to another, can change. So that's why it's important to give you a consistent results, a consistent snapshot of results in a specific time. So in this way, you can specify, look, I have a window for 30 seconds. So if I call the next page in 30 seconds, I will get back the original snapshot results. So in this way, you don't have an inconsistent, result, because maybe, I don't know, you have a very high-intensive application that performs a lot of index update. You run a search and gives you 1,000, results. And the next time you go to the second page, the number of results will change because, again, the data behind the sheet change. So you don't want to have this kind of performance. So this is a cool feature of Elasticsearch. They say, look, I want to have a snapshot of the results, and this is the time frame where the snapshot basically lives from one request to another.
I think a good example of this is on the security side. I mean, if you're looking for the latest events and you're wanting to scroll through them,
Yes.
if you're doing any type of management for a large, company, you're going to have thousands and thousands of entries happening every minute. So
Yeah.
you want to be able to one, make sure that if you were working on one, you can you give yourself enough time to be able to actually look at the things that are happening. And there are plenty of ways to make sure we go about doing that. And where in this case, we're just saying, give me all of the data. You could say, give me all the data that happened, within a certain time frame. But
Yes.
as things continue to update, if you didn't do this, every time you would go to a new page, you would just see the same old data over and over and over. You're like, wait a minute, I'm trying to see the next 10 results. Well, if 10 new results happen, then of course you're going to keep just seeing that same old data every time. So I think that this also is a way to do that. Isn't there another way to look at the actual snapshot as it was collected? And I might be wrong about that, but I thought there was a way that you could say, in this search, that search itself has kind of a snapshot, and that snapshot kind of has its own ID. So you can search based on the results in that particular snapshot.
Yeah, but this is something different. So this is basically the search where the snapshot is internally into Elasticsearch. Of course, if you have your snapshot, you can just specify, oh, look, I want to search into this snapshot, specific one. So this is more internally, but you're right, there is a way to specify when you create your snapshot, look, I want to search into this. Maybe this is a good idea to have, snapshot for, you have a logging system, you have snapshot daily, so you want to just search into that day, and you can, perform a search in that snapshot as well. So
yeah, I think I was conflating two things, and how Elasticsearch.
No, the idea is the
internally.
same. Yeah, but it's the same. But this is, I call it a snapshot because this is how Elasticsearch actually perform this operation, but it's not, public in the sense that you can specify the name of the snapshot.
Gotcha.
The other parameter is the size. So this is the number of results per page. So we want to increase it, I don't know, 50. And of course, you have to specify the query. Again, we want to match all. And this is interesting because the API of Elasticsearch sometimes uses empty object. So just to give you an example, in JSON, an empty object is basically this. How we can map a JSON empty object into an associative array in PHP? We need to create an empty object. But as you know, we don't have actually we have it, but not a lot of people are familiar with this, standard class. So this std class is basically a standard class in PHP. So when you want to create an object, an empty object, you can just create an instance of this standard class. And this is actually the trick that we use at the JSON encode and JSON decode, that are the two functions of PHP in order to encode a JSON and decode a JSON, uses internally to convert this empty object, into this one in JSON. Anyway, long story short, each time you see in your JSON API of Elasticsearch something like this, an empty object, remember that if you are using associative array in PHP, you need to specify this new standard class. Okay, so basically this perform a search, giving the first page with 50 results. And how we can actually scroll, go to the next page. There is this scroll ID that is basically an ID that gives you the the information about the pagination, actually. Because if you use this sequentially, here basically what I'm doing is, while total number of the results is greater than 0 because the results are under the its dollar results. So here basically say if this exists and the count of this I store it in dollar $tot. So while dollar $tot is greater than 0, I perform this while loop. And inside this while loop, I just, print. You can do here. You can perform whatever you want. You have to store the scroll ID because the scroll ID is the one that gives you the information about the ID where you are in the snapshot, basically. And in order to go to the next page, you have to perform a scroll operation. So you are not performing a search. So the search only the first time. If you want to scroll into the results, you perform a scroll API. And very, very simple. You need to specify the scroll ID and again the time frame that I use the same value, 30 seconds. And the scroll basically is a search under the next page. That's it. And again, because I'm updating the dollar results each time, I will have it here, the new information as the new scroll ID, because this will change from one page to another, basically. And with this simple while, you can just perform the pagination and read all the information for all the API. So let's run it. Just I didn't print all the documents. I just say page 1, founded 15 documents, and so on. As you can see, there is one spare documents. So there is page 21 that contains just one documents. I don't know if there are any questions or if you have any question.
You have me thinking, because I've built plenty of projects before where it's like, give me the results, and I've never really played around that much with scroll, but seeing it it makes a ton of sense. But being able to also look and see, like, you can store everything and look at the scroll ID and just say, like, as you said here, page 1, page 2, page 3, page 4, and use that in your own system to
yes,
move
exactly, to move around. Yes.
Yeah. So that's making me think a lot about, like, now I need to go back and look at, like, all of my projects and be like, how do I implement scrolling, properly in this?
Yeah, that's also interesting idea. You have to play also with this time frame, because this is actually very important, because otherwise you're storing some scroll ID, and if you don't perform any scroll in 30 seconds, the snapshot will be destroyed, basically.
Yeah.
There is a limit about the scroll. I don't remember. It's some 5 minutes, something like that. But generally speaking, it's more than enough to cover the majority of the use cases.
So, just trying to think, what would be the best way to do that? Because I'm sitting there thinking from a traditional search standpoint, like an example on, like, a website where you say, hey, there were 5,000 results. Here are the first 30. What if someone just sits there and hangs out on that search, for too long? I wonder if there's a kind of a systematic approach to saying, like, hey, if the next search is after this time, you have to re-execute the search, otherwise you're going to run into some issues.
Actually, yeah, that's a good question. There are a lot of possibility here. So this is more in a scenario where you have a lot of data coming, updating. So that's why I use 30 seconds. So
Yeah.
Imagine that you want to perform a search into log. If you perform a search and after 5 minutes you perform another search, you don't want to see the 5 minutes ago log, because maybe you are interested in more updated data. So this is more for this kind of scenarios.
If
But
that timeout has happened and you try to search, you try to continue the scroll, will you receive an error? Because it may just be, again, error catching.
no, you don't have an error. Actually, you can have inconsistent results, because maybe the number of total documents are changed, And that's why. So this is more a parameter to be sure that the results that you are giving back are according to the snapshot that you call it into the time frame. You know what I mean?
Yeah, that makes sense. And this is why I enjoy doing these, because it's like, hey, today I learned a little bit more of how the scroll process works in this and how to effectively use it. So
yeah, there are tons of internal details that are very specific to the implementation of Elasticsearch that gives you that you open the door for a lot of scenarios like the schema on read. Don't know if you're familiar with the latest
yeah,
feature that we introduced. It's opened the door to a completely new approach, because from my knowledge there is no other solution in the market that give you the possibility to change, to add a field in the results when you are reading the information without changing the information. This is quite crazy if you think about it.
yeah.
So open. I'm sure we will see a lot of interesting, application and use cases in the future.
Well, cool. Well, I think we're running up. Well, we're actually running a little bit past time, but thank you for. I mean, the extra time went towards this, so I thank you for that because I learned something today. But
Yes.
do we have any other things that you wanted to point out?
Um, Let me think, because I have a lot of example here. So I provided, yeah, maybe something that I didn't tell about the mapping. This can be interesting. So basically, when you in the example that I show you, we just have some documents, associative array or JSON, and we just put the document inside Elasticsearch. We didn't care about the mapping, so the type, basically, to have, for instance, in the SQL world, where you have database, relational database, you have to specify the structure of a table, no? You have to specify this field is a varchar, is a string, integer, whatever. I didn't write nothing. If you remember the example that I show you, I just pick up a random JSON and then put it into Elasticsearch. So we say that Elasticsearch is schemaless. So because we didn't provide any schema, but this is not true. So inside Elasticsearch generate a schema that they made as mapping in order to understand, okay, this looks like a string, so I will use a string. This look like a number, I will use the type number, and so on. So this is quite powerful, because you don't have to think about nothing. But of course, when you start going more deeply inside your application, you may recognize that maybe you need to change something, because you want that something is not a text but is a term, and etc. So there is a nice API that is mapping. Actually, this is the first example of API into Elasticsearch PHP that has a namespace, because typically, I mentioned we have almost 400 API in Elasticsearch. We also collect together using namespace. So there is, for instance, all the API that performs on indices are under the indices namespace. And this is an example, get mapping. You have just to specify the name of the index, and this will give you the results of the type used internally by Elasticsearch to manage this index. So if we actually run this example for each field, and remember the example that I show you are count number, address, age, for instance, as you can see, age automatically, because age was a number. Automatically, Elasticsearch is able to understand, okay, look, this is a number, so I will use the type long. For instance, the account number, the same long. Address is more complicated because it's a text that contains some keyword with maximum 256 for the keyword. You have city, the same is a text. The email is a text, etc. So you can see using this API how Elasticsearch manage internally the accounts index in this example. But imagine that you want to change it because, I don't know, maybe the gender, that is actually, if we go in the example, gender, as you can see, is just M or F. I don't want to use text for this. Maybe it's better to use, term for this, because term is internally in Elasticsearch is a type that gives you the possibility to perform a very, performant operation using this term, like not a full text, but a specific term. So long story short, we want to change it, this mapping. How we can do this? We can use the under the same namespace indices, they create. So we want to basically create, because if basically an index already exists, you cannot change the mapping. You have to re-index the index. Or imagine that we want to actually create from scratch a new index that is a count. You can specify in the body the mappings. And as you can see here, for each property, first name, last name, gender, etc., I'm specifying that is a keyword. This is the type that I want to use it. Is basically we want to perform a term operation on this type, on this fields, and the keyword is the one that we need to use. So basically, if of course now I need to delete the index. This is another API that I didn't show you, but this is just basically this delete the entire index. We can execute this create index mapping. We can, I don't know, perform a bulk operation to put some data. And now if we go back to the mapping, as you can see, the first name now is a keyword. The last name is a keyword, and gender is a keyword. Why I did this? Because now I can do very, very advanced stuff, like I don't know, for instance, aggregation. Aggregation is a way to aggregate data using keyword. You can do also in text, full text, but of course it's not so performant. So now that I have aggregate, I can, for instance, answer a question like how many male and female we have in our database, in our accounts. Because now we have a keyword for the gender, I can aggregate, and this is actually the way to aggregate data using the AGS terminology, AGS field in the body, and we can perform just a search. So search is a lot of different body type of body requests. Anyway, if we perform this, and this is actually search aggregate, you can see this is the result. So basically, Elasticsearch provide aggregation, and this is are the numbers. So basically, in the accounts index, we have 505 male and 494 female. This is an example. And in order to do this, again, I needed to specify that the gender field is a keyword. Otherwise, this aggregation will not be possible or not so performant. And as you can see, we did this in 46 milliseconds. So very, very fast.
Yeah, I've learned a lot in the art of making sure that your mappings match what you're trying to accomplish. And funny when you mentioned, adding that delete and bulk indexing again, that takes us all the way back to that first part about ignoring certain errors of why I had to do that, because I actually did have to do that for this exact reason of changing my mappings. It was like,
yes,
all right, well, these
exactly.
mappings are wrong. Let me reindex everything, but that means I have to go in and delete it first. And it's like,
yes,
you know what?
yeah.
I'll just build this into the code so I don't ever have to think about that again.
Yeah, this is the general path when you learn how to use Elasticsearch. You don't care at the beginning about mapping, but when you are going deeply into the search, you're starting to recognize, look, okay, I need to aggregate this. I want to search using fuzzy search here. So it's better to use keywords, so I need to remap. So usually it's a process, it's a very agile process, I would say, because you change your code according to your needs. and you start using this mapping in the second phase, typically, when you have to play with the search.
Absolutely. Well, let's start wrapping up here, and I wanted to give a little bit of time to talk about what's coming up next. So 7.14 is out. 7.15 will be out at some point, and then I know everybody's looking forward to 8.0 coming out. How does this release cycle affect you on the PHP side? What can people be looking forward to in terms of PHP?
So we are working since the beginning, actually, to the 8 version, because basically now we have type internally. So we know how to create the request and how to create the response for Elasticsearch, because we mapped all the possible scenario, all the possible input and output. So basically we can create an object-oriented way to create the request and giving back the response. So no more associative array, because one limit is very powerful. It's very simple. As I show you, a couple of lines, you put the JSON or the associative array, you index, and you're done. But if you don't know how to write the JSON or the associative array, this can be, a limit, because you have to go to the documentation to understand how to create, or some example, and so on. Imagine that you have something that you can autocomplete. You start doing like a new search request, and you have all the possible, parameter just as a property of a class. This will simplify a lot the usage, the developer experience. That's the goal. So we want to have a client that gives you the best developer experience possible. So the Elasticsearch PHP 8 that will be released next year, of course, when Elasticsearch 8 will be released, will have this kind of power. Of course, this can be a breaking change for a lot of projects. So we are thinking also to have a way to provide backward compatibility, maybe having an old legacy client that performs like the one that I show today. So the 7 will be the 8 as well. But we want to give also the possibility to have a more high level, structure for creating request and response. So this is the biggest, news. And also in PHP special, I'm leveraging the fact that we have now PHP 8 with a lot of nice feature, like named arguments in the function. So you don't have to specify the order of the parameter. You can say the ID parameter is this one, the name is other. So you can actually change the position of the parameter. You don't have anymore in PHP something annoying like optional parameter that is the third, and you have to pass as the second parameter a null value in order to get the third one, and so on.
Yeah.
So Elasticsearch 8 will leverage PHP 8. So this is also nice combination, because we have the same major version, and 8 for PHP and 8 for Elasticsearch. So it will be very nice. If you want to have a kind of preview about what we are working on, we released another PHP client that is Enterprise Search PHP. And this is the URL where you check it out, that actually use this approach. So I recently released this client, so I used the new technology that I was building on, and this actually uses a common library that is Elastic Transport PHP. That is another open source project that we deliver in order to have one common, core for providing HTTP communication between client and server application, not just Elasticsearch, because the majority, I would say the total of our products in Elastic are REST API. So the idea is, okay, we build this kernel for HTTP transport. So this library will be used by all the PHP projects, all the PHP client that wants to communicate to enterprise search, to app search, to workplace search, Elasticsearch, and etc. That's why we built this library. And this actually use also PSR 7 standard that are standard in the PHP world. We don't have anymore the internal details that we have with Gazelle or Ring PHP in the previous in the actual Elasticsearch PHP client. So we are trying to leverage the new technology in the PHP community, even because I'm part of the PHP Fig organization that provide a standard for the PHP, so I have to use it. You know what I mean?
I get that. Well, thank you. And again, this is one of these series are important to me because I am a clients person. I am a person that as much as I love the Elk stack, and we're even going to be talking about parts of the Elk stack with Logstash in a few weeks, but I tend to want to go, I'm writing a project in this language. How do I interact with Elasticsearch using that language instead of having to now use two different pieces of the overall project? But thank you so much, Enrico, for taking some time out. I know that you're in Europe, so it's actually a little bit later. So thank you for meeting with us so
No
late in the
problem.
day for you.
No problem. My pleasure.
I see you have your Twitter handle there. I guess if people want to get in touch with you, they can do so
Absolutely.
there. Of course, if you had any questions about PHP that we didn't cover or the PHP client for Elasticsearch, you can do that over at discuss.elastic.co. And stay tuned over at community.elastic.co, where we'll be talking about what we have coming up. Not sure what's going on with the live stream for next week, but I think there might be something involved. Keep a lookout for that. As always, if you're not yet subscribed to the channel, if you like this presentation, give it a thumbs up. That helps us know. And let us know in the comments what you want to see next in this series. But that's going to do it for this week. And until next time, for Enrico and myself, we'll talk to you later.